गुड मॉर्निंग, नमस्कार. एम आई ऑडिबल? क्या मेरी आवाज पहुंच रही है अब तक? Please check audio and video so that we can proceed for today's discussion. In the last class, we started to study about the atomic structure. We discussed a few basic atomic structures and then started to discuss about the Bohr's atomic model. We dealt with three important points of Bohr's atomic model. In the first point, Bohr is trying to say that the electron in the atom can move around the nucleus in a circular path of fixed radius and energy. These paths are called orbits. Stationary states are allowed energy states. Second statement is giving an electron can move only in those orbits for which its angular momentum is an integral multiple of h by 2 pi. That is why only certain fixed orbits are allowed. Third, when electron jumps from an orbit of higher energy to another orbit of lower energy, then energy is released in the form of radiations and vice versa. The amount of energy released or absorbed is the difference of energies between the two orbits. So this is all about the Bohr's model. These orbital radius can be calculated. So although I am not going to derive the relationship, those who have studied EDC, they may have derived this, because in the EDC classes I used to derive all the relations. But here, keeping in mind the limitation of time, as we have been allowed very less time to study lots of things, we are not going to derive the relationships. Also not required because it is objective examination. So just directly let us see how, what is the value of radius of orbits. Suppose this is nucleus and this one is your first orbit. This one is your second orbit. This one is third orbit, like this. So n is equal to 1, n is equal to 2, n is equal to 3, suppose this. For the first orbit, the radius is r1. For the second orbit, the radius is r2, and for the third orbit, the radius is r3. Likewise, we can proceed. So Bohr's orbital radius, यानी बोहर के ऑर्बिट्स की रेडियस, बोहर्स ऑर्बिटल रेडियस इज गिवन एज बोहर्स ऑर्बिटल रेडियस, आर एन इज 0.529 n square by z angstrom. Here n is number of the orbit. It has value equal to 1, 2, 3, 4 up to so on, and z is atomic number of the element. Atomic number of the element. My dear friend, you see one very important point here. Z is constant for a particular element. Atomic number कभी भी change नहीं होता. It does not changes. It means what? Bohr's orbital radius are the fixed values always. For the first orbit it is r1, second it is always r2, third it is always r3. It does not depend upon the external conditions, like it does not depend upon the temperature, it does not depend upon the pressure, it does not depend on any other external parameter. Even if it does not depend on ionization, suppose ionization of atom took place, so either one electron is leaving the orbit or one electron is coming to the orbit. If electron is leaving to the orbit, it is going to become positive ion, and if it is coming to the orbit, it is going to become the negative ion. But in any case, the radius of the orbit is not changing. So these orbits are basically the fixed positions in the space that do not depend even on the ionization of the atom. Please keep this point in the mind, because after a few moments I would be giving you one question and you would be using this point in that question. Also, I said in the last class that when an electron is moving in a particular orbit, its energy is constant. So we can calculate this energy also. E1, the energy of the first orbit, E2, the energy of second orbit, and E3, the energy of third orbit, likewise. So energy of electrons in the Bohr's orbit can be given as energy of electron in Bohr's orbit. In Bohr's orbit. Energy of electron in Bohr's orbit. That is given as En is equal to minus 13.56 Z square upon N square electron volt. First of all, you see here N is 1, 2, 3, 4, 5, 6 like that, and Z is atomic number of the element. Here I am using EV one term. This is read as electron volt. It is read as electron volt. This electron volt is nothing but the unit of energy. It is unit of energy. It is unit of energy. ये एनर्जी की यूनिट है. आप कहोगे जी कि to measure the energy we have one unit, that is joule. Then why do we need this? Joule is very large unit. Joule is very large unit. Suppose I want to say you to measure the length of this pen. So you will not be measuring it into kilometer. If you are measuring it into kilometer, you are an idiot. You would be measuring it into the smaller units of length like centimeter, millimeter or inch you would be using. So similarly, joule is very large unit for the particles like electron, for the energy of the particles like electron. So we have defined a smaller unit, and that smaller unit is known as electron volt. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. 1 electron volt is this much of the amount. This is the value of 1 electron volt, right? My dear friend, let us suppose we want to plot this energy. Suppose I am plotting it for hydrogen atom. In the hydrogen atom, atomic number is Sadhna ji, I think you missed the yesterday's class. I know people have problem with Hindi and English. I talked with the management also, right? But merely by talking, just talking with the management, the things are not going to happen in your way. You have to write to the MEDICI management and tell your problem that you are not comfortable in the in English language, and teacher is teaching totally in English. The reason behind is in this batch, 2 batches are mixed. One is Hindi batch and other is English batch. And I have been told by the management to teach in English. You know, I am doing a job. So I am bound to follow the instructions given by the top management. So I am following those instructions. It's not possible to repeat each and everything in both of the languages. That's not possible. I should teach in Hindi and English both simultaneously, because already very less time is given for such a lengthy subject. It's not less time is given, actually that the time defined is tightly whatever is the required, that much is the time given. Now if I deviate, then it take almost double of the time, which will not be feasible for me to allot that much time. So I will advise again ki write to the MEDICI management. They may be getting some solution for you. They may be telling me to teach either in Hindi or telling me to teach either in both of the languages, or maybe they would be separating both of the batches. They may be separating the English batch and Hindi batch. That's the only solution, right? Come back to the problem. So I said that let us plot this energy for the hydrogen. For hydrogen we have Z is equal to 1. हाइड्रोजन के लिए हमारे पास Z की वैल्यू 1 है. Let us suppose I am wanting to plot energy for hydrogen. So for hydrogen Z is equal to 1. Atomic number is 1. Suppose this is the edge of the nucleus. This point is edge of the nucleus. So you draw like this. This point is edge of nucleus. Edge of nucleus. And now we are going away from the nucleus. In any direction you go away, either in this direction or in this direction or in this direction or in the direction, because energy at each point in an orbit is same. So let us suppose we are going at this point, this point, this point, and likewise. So moving away from the nucleus, moving away from the nucleus. And now I am wanting to plot the variation of energy of electron. So on this axis we are plotting energy of electron. Right. First of all, we went to the first level, this point, n is equal to 1. So for n is equal to 1, let us suppose we have taken z is equal to 1 for hydrogen, just for simplicity of calculation. Then it comes out E1. E1 is minus 13.56 electron volt. Right. Then n is equal to 2. N is equal to 2 is E2. E2 is minus 3.39 electron volt. You put the value of N2, then you would be getting this. In the same formula, in which formula I am telling? En is, I told you the formula to calculate the energy is what? En is minus 13.56. Z square is 1 upon n square electron volt. So n is equal to 2, you will be getting this value. Let us suppose we put n is equal to 3. So when I put n is equal to 3, then the value is E3, and E3 is minus 1.51 electron volt. Let us suppose we keep on moving and I go to the infinite orbit, E infinity, then the value would be 0.00 electron volt. This would be the graph of energy of the electron when we are moving away from the nucleus. जैसे जैसे हम न्यूक्लियस से दूर जा रहे हैं, इलेक्ट्रॉन की एनर्जी किस तरह से चेंज हो रही है, दैट आई एम वांटिंग टू प्लॉट हियर. One very important observation, my dear friend. The energy of the electron around the nucleus is negative. What does negative energy signifies? I am going to tell you very soon. But as of now, you just keep in mind कि energy of the electron when it is moving around the nucleus, that is negative. And we all know that if the magnitude of negative number is smaller, then the value would be higher. So the largest value of energy is E3, then E2, then E1. So we can say that in these energies, E1 is the smallest one, E1, then E2, then E3, then like that E infinity. So one big conclusion is that as we are moving away from the nucleus, energy of the electron is increasing. जैसे जैसे हम न्यूक्लियस से दूर जा रहे हैं, इलेक्ट्रॉन की एनर्जी बढ़ती चली जा रही है. As we are moving away from the nucleus, energy of the electron is increasing, right? So closer the electron to the nucleus, lesser is its total amount of energy, and away is the electron from the nucleus, far away from the nucleus, higher is its total energy. First thing. Second thing, you see, first you draw all these things. From here you draw it, then I would be here onwards today's class we started. First you draw it, then I would be explaining few important point here. You draw this all energy and whatever I have told. No, dear Brijesh or Sadhna or Saurabh, I have been told to teach in English. I am not your enemy. I am your teacher. I am not your enemy. I would be telling a lie to you. I would be telling, I don't enjoy to trouble you. I am bound by the rules to follow it, right? So I was told to speak in English in this batch, that's why I am speaking. I don't know what communication has been done with you, but with me the communication is done like this, this is the morning batch and this is for GS, for all the branch students are in this batch, and I have to continue in English medium. So talk to them. Someone has written that कि सुबह से शाम तक क्लास चल रही है, morning night. अब भाई सुबह शाम तक क्लास चल रही, बहुत लेट एडमिशन लिया होगा आपने, तो सिलेबस पूरा करने के लिए सुबह से शाम तक क्लास चल रही होगी, उसमें मैं क्या कर सकता हूँ, आई कांट डू एनीथिंग। सो आप 10 मिनट का समय निकालिए, बात करने की कोशिश करिए, ठीक है। तो मैं हेल्पलेस हूँ, अगर आप नहीं समझ सकते तो कुछ नहीं किया जा सकता। Revati Nitin said that, sir, have you received any message regarding language of teaching? We have already contacted with management. Up till now, I have not received any communication. Maybe the reason is that till 8:30 I was having class in the night, and after the class I went to the home, and then coming now. It is very early morning. Staff, the management staff used to come by 10 o'clock. So maybe after 10 o'clock when they come and they may give some information. But as of now, I have not been given any information. 5 मार्च को एडमिशन लिया, तब भी मॉर्निंग से इवनिंग तक क्लास चल रही है, ऐसा कैसे हो सकता है? मार्च के बैचेज में तो मैक्सिमम सिलेबस कवर हो गया है, ओनली जीएस में भी लेफ्ट। You talk to the management, definitely they will come out with some solution. निश्चित तौर पर वो कुछ ना कुछ solution लेकर के आएंगे. You write them, and that's why I'm little bit slow also. Okay, once the communication is done, in which language I have to continue, then I will take up it. No, you do not need to remember all the, you need to remember these two formulas, but you need not to remember the values of individual energy levels, E1, E2, E3, not required. Just trained when we are going away from the nucleus, then the energy is increasing. Now come to the point. Suppose I talk about the force, suppose there is an electron at this place. So force on electron is 1 by 4 pi epsilon naught plus q1, the charge of nucleus, minus q2, the charge of electron, divided by r square, where r is the distance between these two charges. If any electron is in the first orbit, then r is minimum, and if r is minimum, the force is maximum. If r is minimum, the force is maximum, and the attraction force is maximum, energy is minimum, energy of electron is minimum. So if an electron is very close to the nucleus, it is tightly bound by the nucleus, it is heavily attracted by the nucleus, and its energy is minimum. That we can conclude from this graph. Another thing you see, suppose an electron is in the last orbit, far away from the nucleus. So when it is far away from the nucleus, the distance r is very large, and if r is very large, then the force will be minimum. So electron is loosely bound to the nucleus. If it is in the last orbit, then r is large, distance between the charges is large, and force is less. So if the force is less, it means it is loosely bound to the nucleus, and energy is maximum. In that case, it will have maximum energy. If the force is less, energy is maximum. One more thing you see, My dear friend, if R has some finite value up to this point below infinity, R has some finite value, and if R has some finite value, then electron will definitely be attracted by the nucleus. If R is finite, then electron must be attracted by the nucleus. And if electron is attracted by the nucleus, then it will be moving around the nucleus only. It cannot be considered a free particle. Free particle means it can move from here to here anywhere. But it is bound to move only around the nucleus. So such electrons which are moving under the attraction force of a nucleus, they are known as bound particle. Bound particle. Particle means electron. Bound electron. They are moving only around the nucleus. They are not free to leave this nucleus because they are wanting to leave, but as soon as they are trying to leave it, this nucleus is attracting them, so they are bound to the nucleus. They cannot leave it. Energy of bound electron. Energy of bound electron is negative and quantized. Energy of bound electron is negative and quantized. Quantized means discrete. Electron can have this energy or this energy. It cannot have energy in between these two limits. So its energy is quantized. It is allowed to take certain fixed values of energy. It cannot take every value of energy, as well as its energy is negative. But suppose an electron goes to this level. An electron goes to this level. N is equal to infinity. N is equal to infinity means R is equal to infinity. And R is equal to infinity means force of attraction is 0. So now nucleus cannot attract this electron. If any electron is going far away from the nucleus, far away from the nucleus means infinite distance, then now nucleus will not be able to attract this electron. Force of attraction of the nucleus is 0. If nucleus is not able to attract this electron will not be coming closer to the nucleus. It is going away. So this electron is free from the influence of the force of nucleus. So this electron can move anywhere in the material. Such electrons which are free from the influence of their parent nucleus, they are known as free electron. So this electron is free electron. My dear friend, you see the energy of free electron is 0 or more than that, means positive. So this energy is positive. Energy of free electron is positive. Energy of free electron is 0 or positive, and it is continuous. And it is continuous because quantization rule is not followed here. Quantization is because of MBR is equal to NH by 2 pi, and that is valid only around the nucleus, but this electron is free from the influence of the nucleus. My dear friend, which electron is more important for us, the bound electron or the free electron? Suppose I want any current. So in order to get the current, the charge must flow from this point to this point. So only free electron is capable of moving from this point to this point. The electron which is bound, that will be moving only at this point. It is not able to move from one place to the other place. So bound electrons are not going to give a contribution into the electrical conductivity or any property in fact. The electrons which will become free from the influence of their parent atoms, they are going to contribute into the material properties. But isolated existence of electron is not possible. Electron is always found around the nucleus. So what does it mean? It means that we have to make that electron free in order to get certain electrical property, mechanical property, or any property, chemical property, anything. In order to get a certain characteristic from that electron, we have to make it free. Which electron can we make easily free? In order to make electron free, its energy should be 0. Minimum energy should be 0. Suppose I want to make this electron free. So its energy is minus 13.56. If you want to make this free, you have to supply plus 13.56. Means very large amount of energy is required to make this electron free from its orbit. But suppose I want to make this electron free. So since this electron is already having very high energy, we need to provide only 1.51 electron volt, plus 1.51 electron volt. If we provide only this much of amount of energy, this electron will become free and this will leave its orbit, and now it will participate in several activities. Whatever we want, it will participate in that activity. So I am wanting to conclude that it is very difficult to knock out an electron from the inner orbit, but it is very easy to knock out an electron from the outer orbit. And this is the reason why outer orbit electrons participate in chemical bonding, participate in electrical conductivity, participate in other properties of the material. So here onwards we will not bother about how much total number of electrons are available in the material. Instead, we will bother about how many electrons are in the outermost orbit, because those electrons can be easily knocked out of their orbit and they may participate in various activities, and hence they would be contributing into the material properties. And in this subject we are bothering to study about the material property. So these outer orbit electrons are only important for us because they have higher energy and they are far away from the nucleus, so they are loosely bound to the nucleus. So it is very easy to take them out. It is very easy to knock them out. And once they come out of their nucleus, the influence of their nucleus, they will participate in bonding, they will make solid, they will participate in conductivity, they will be doing everything. The outermost orbit is known as valence orbit, and the electrons in the outermost orbit are known as valence electrons. So here onwards we would be valence orbit, valence electrons. Here onwards we would be interested only in the valence electron, not in any other electron. This modification in the diagram you can write, and then we would be moving for the writing these things which I told you. You can write this pre-electron concept and bound electron concept. Now I am just, for the explanation purpose, Gurdeep, I am taking one electron. There can be 2 electrons, 8 electrons, that I would be telling you at the end of this lecture how many electrons can be in one orbit. It is just for the explanation purpose I am taking one electron. Yes, Akhilesh, when electron get energy, they would be jumping from one orbit to the another orbit, and you provide sufficient energy, then they would be going for the infinite orbit, last orbit, right? Infinite means far away from the nucleus, and then the force of attraction of the nucleus will become 0. Yes, Giri, you see the energy is negative for the electron, and 0 is greater value than the negative. Aslam Khan is saying how energy is minimum when force is maximum, whereas energy is equal to force into displacement. You are talking bullshit, you are talking Newtonian physics, which is not applicable on the particles. Infinity, I am not, sorry Kumar Singh, I am not telling infinity is energy, infinity is distance, right? And infinity is nothing but a concept. Infinity means far away from the nucleus. So in terms of atoms, a few micrometer will be far away from the nucleus, that would be considered as infinity. कहाँ से concept लाते हो ऐसे? सुबह सुबह गोला वोला लगा करके बैठ जाते हो क्या? Yes, energy of free electron is not quantized, because quantization rule Bohr gave only for the electrons which are moving around the nucleus. For them MBR is equal to NH by 2 pi. But if electron is free from the force of the nucleus, then MBR is equal to NH by 2 pi is not valid, and if that's not valid, then energy cannot be quantized. And that was the reason early researchers were confused. When electron is far away from the nucleus, its energy is continuous, means it is behaving like a wave. But when it is closer to the nucleus, its energy is discrete, it is behaving like particle. So early researchers were not able to figure it out, how it is behaving like a particle, how it is behaving like a wave, and that's why they got confused. Now you can conclude it simply, if the electron is very closer to the nucleus, it would be behaving like a particle, because its energy is quantized, it may take certain discrete values of energy. And if it is far away from the nucleus, then its energy is continuous. Continuous means just like wave, so it is behaving like a wave. Now we can conclude that electron can behave like both as particle as well as wave. Yes, Achilles. First, it's not necessary to knock out all electrons before that, but obviously to knock out an electron from n is equal to 1, you need to supply the very high amount of energy, and if you supply such high an amount of energy, then all the electrons before the first orbit will be knocked out. Abhishek is saying, can we say that material science is chemistry rebranded? No. Material science is amalgamation of all the engineering branches as well as science. अभी तो just शुरुआत है. Quantization means discrete. Quantization word is taken from Hemant. Quantization word is taken from quantity. Quantity means which can be counted. The things which can be counted, they cannot be continuous. Like 1, 2, 3, 4, 5. Suppose apples. So you will have 1 apple, 2 apple, 3 apple, 4 apple, like that. So that is quantized. मैंने हाइड्रोजन जस्ट फॉर सिंप्लिसिटी के लिए लिया था, जस्ट फॉर सिंप्लिसिटी ऑफ कैलकुलेशन, बिकॉज हाइड्रोजन के लिए एटॉमिक नंबर इज 1, सो आई टेक इट फॉर सिंप्लिसिटी ऑफ कैलकुलेशन. Z is equal to 1. You can take any other element as well, but I took Z is equal to 1 just for simplicity of calculation. Written? Let's write few things. The greater the distance of an electron, greater the distance of an electron from the nucleus, the greater the distance of an electron from the nucleus, higher is its total energy. Higher is its total energy. The greater the distance of an electron from the nucleus, higher is its total energy. Yes, these energy values are only for hydrogen atom. For other atom, you have to put the value of Z as well, and accordingly the value will change. I have calculated all these values considering Z is equal to 1. ये विजुअल नहीं था किसी लोग को, देख लो. Do it quickly. Mukul, these are for the hydrogen. The greater the distance of an electron from the nucleus, higher is its total energy. Next point. An electron orbiting very close to the nucleus, in the first cell, या orbit, whatever you are wanting to write, you can write. In the first cell, is tightly bound to the nucleus, tightly bound to the nucleus, and possesses greater amount of energy, possesses, sorry, smaller amount of energy, possesses smaller amount of energy. An electron orbiting very close to the nucleus in the first cell, first T होना चाहिए, in the first cell is tightly bound to the nucleus and possesses a smaller amount of energy. So it would be very difficult, to knock out this electron from its orbit, On the other hand, an electron orbiting far from the nucleus, in the outermost cell, that is valence orbit, is loosely bound to the nucleus, is loosely bound to the nucleus and possesses greater amount of energy, So this electron can be easily knocked out of its orbit, This is the reason why valence electrons participate in chemical bonding, etc. Please note down this. Arey Joseph, for other atom energy formula is written Z square, Z value put you, Z is what? Atomic number. कहाँ तुम लोग यार क्या पढ़ते हो, मतलब highly disappointed with the type of questions. ये तो छठवीं सातवीं में पढ़ने वाले बच्चे को समझ में आए. Z square is written, En is equal to minus 13.56 Z square upon N square is written. Z is atomic number. It means जिस भी एटम का atomic number put कर दोगे उस एटम का एनर्जी मिल जाएगी आपको. अभी थोड़ी देर पहले कोई लिख रहा था कि एनर्जी कैसे हो गई, फोर्स इनटू डिस्प्लेसमेंट. अरे बेवकूफ़, यहाँ कहाँ डिस्प्लेसमेंट हो रहा है. मुझे हंसी आ रही थी, मैंने नेग्लेक्ट कर दिया कि अब मतलब बीटेक करने के बाद ऐसी भी बातें कर रहे हो कि कोई भी एक ही चीज़ हर जगह अप्लाई कर रहे हो. यहाँ कहाँ डिस्प्लेसमेंट हो रहा है. इसका मतलब डिस्प्लेसमेंट की वजह से तो एनर्जी है नहीं, एनर्जी का कोई और कारण होगा. बट एक फार्मूला रट लिया है कि एनर्जी इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट. अब सब जगह वही लगा देना है, चेप देना है. थोड़ा ग्रो अप करो, थोड़ा समझो, ऐसे बनोगे आईएएस. अभी तो एक पेज छोड़ दो शुभम, एक पेज ही हुआ होगा। आइए, Bohr's model was able to explain several things, but it has certain inherent limitations. One limitation is it could not explain about the effect of electric field on the electrons as well as effect of magnetic field on the electrons. But these are not the big thing. The big thing was there was a big scientist named as Heisenberg. Heisenberg says that for a moving particle it is impossible to simultaneously measure momentum and position accurately. He is saying that we cannot measure precisely the momentum and position of a particle when it is moving. Means there must be some error in the measurement of position as well as there must be some error in the measurement of momentum if the particle is moving. This is known as Heisenberg's uncertainty principle. अभी थोड़ी देर बाद मैं लिखाऊंगा, लेकिन जरा देखें. Bohr is precisely measuring the position. This is nucleus and he is saying that electron is at this point from the nucleus. It is moving at this point around the nucleus. So from nucleus its position is fixed, and if its position is fixed, delta x is what? 0. And if delta x is 0, then this inequality cannot be satisfied. So if you talk about the definite position of electron around the nucleus, it means you are violating the Heisenberg's uncertainty principle. But Heisenberg's uncertainty principle is not assumption, it is not postulate, it is mathematically developed theory. So obviously Heisenberg's uncertainty principle is more proven fact than the Bohr's assumptions. It means Bohr is doing certain mistake when he is saying that electrons are moving in a particular orbit of a particular energy. This statement need a little bit correction. So Bohr's model is not 100% true. There is some error in the Bohr's model also, and that error is indicating that electrons cannot be at definite position, because Heisenberg is trying to say that we cannot precisely move the position of a moving particle. So if we cannot precisely measure the position of the moving particle, then how can Bohr's model be correct? So it is the inherent problem with the Bohr's model. How this problem was overcome, how the concept of modern concept of atomic model came into the picture, that I would be discussing. But before that I would like to discuss one very important theory, and that is related with Planck's quantum theory. Once I discuss with Planck's quantum theory, then I will enter into the Heisenberg's uncertainty principle and the modern concept of atomic model. So next heading is Planck's quantum theory. Achilles, beta, negative energy is signifying that the particle is not able to perform any duty. It is not able to perform any work. To perform any work, you must have certain amount of energy, certain positive energy. Then only you can perform some work. And that is the reason why bound particles are not performing any function. They are not participating in conductivity, they are not participating in magnetic properties, they are not participating in bond formation, they are not doing anything for you. Okay? So negative energy means that particle is not capable of performing any job, whereas positive energy means particle has certain amount of energy, it can use that energy to perform a certain job. आइए, Planck's quantum theory. Planck's quantum theory. ये एक जर्मन फिजिसिस्ट थे जिनका पूरा नाम मैक्स प्लांक। मैक्स प्लांक ने एक थ्योरी दी। बिफोर मैक्स प्लांक वी वर assuming that light travels like a wave. Earlier the people were knowing that light is like this wave, means the energy of light is continuous. But Planck said that actually this man was heating iron rod, and when he was heating iron rod he got surprised, he got some interesting results. If you have little bit knowledge about the electromagnetic spectrum, it is like this, UV, VIBGYOR, IR, this you may have read. So he saw that when he increased the temperature, first of all the iron is becoming light yellow color. It means iron is absorbing the energy of frequency having yellow color. This is arranged in the order of increase in frequency. ये ऐसे frequency बढ़ती चली जाती है. Every color has different frequency. So it is absorbing energy of this frequency corresponding to the yellow color, and then that frequency it is emitting, and because of which it is visible of the yellow color. When it further heated, this become red hot. Orange is skipped, and it is not absorbing all the frequencies. Yellow, then red, no frequency in between. Orange is not exhibited. When it further heated, it becomes blue. Again green is left. Again these frequencies are left. It means material is not able to absorb whole light. Instead, it is able to absorb light of certain frequencies. So from this experiment he concluded that light cannot be continuous thing. If it is continuous, then how can yellow, then red, then blue? Why not the whole color? And whole color means it should be visible as white, but it is not white, it is exhibiting certain colors. All the wavelength, all the color means it should be a white color, but the color is not white, it is certain different colors exhibiting or increasing the temperature. It means the energy absorbed by the particles in the material is not continuous, instead it is discrete. And if absorbed energy is discrete, it means the incident energy is also discrete. Discrete means quantized. Quantized means not continuous. Quantized word is taken from quantity. Quantity means which can be counted, like 1, 2, 3, 4, 5, like this. Where it cannot be counted. The wave which is continuous, it cannot be counted. It may take infinite values in between the two intervals. So it cannot be counted. So he proposed the idea, he said that actually this light travels in terms of small energy packets, and when these energy packets fall on any material, one of those packets is absorbed by the material. So he named this packet of energy as energy quantum, या quanta, and later on this packet of energy was known as photon. So he said that actually the light energy is discrete in nature, it is quantized, it travels in the form of small packets of energy, and one smallest quantum of energy, a packet of energy, is known as energy quantum, which was later known as photon. He also said that energy of the photon is directly related with the frequency. How, I would be telling you, but before that you please need to write this. So Max Planck की इस theory को लिखते हैं. कोई बात नहीं असलम बेटा, not valid, that would be valid only if displacement is taking, na, common sense. Here no displacement is taking. अभी किसी को बोहर्स मॉडल की ही स्लाइड में कुछ देखना है क्या भाई, कहाँ रहते हो तुम लोग? Take it quickly. ये तो कल का था। आइए, प्लीज नोट डाउन द मैक्स प्लैंक्स थियरी. Yes, energy packet called photon. Please note down. Planck suggested that Planck suggested that atoms and molecules could emit or absorb energy only in discrete quantities. And not in continuous manner. Full stop. Planck suggested that atoms and molecules could emit or absorb energy only in discrete quantities and not in a continuous manner. Full stop. Planck gave name quantum to the smallest quantity of energy. Planck gave name quantum to the smallest quantity of energy that can be emitted or absorbed in the form of radiation. Full stop. The energy of a quantum of radiation is proportional to its frequency. Some people are saying to repeat it. Listen again. Planck suggested that atoms and molecules could emit or absorb energy only in discrete quantities and not in a continuous manner. Full stop. Planck gave name quantum gave name quantum to the smallest quantity of energy that can be emitted or absorbed, in the form of radiation, full stop. The energy of a quantum of radiation, is proportional to its frequency, देखें जरा, E is directly proportional to nu. So here you would be getting E is equal to h nu, where h is proportionality constant. E is energy of a quantum of radiation, Nu is frequency of radiation, H is Planck's constant, H is equal to 6.626 into 10 raised power minus 34 joule second. This relation can also be written as E is equal to h nu is equal to hc by lambda, where c is velocity of light in vacuum, velocity of light in vacuum, and value of c, you all know that 3 into 10 to the power 8 meter per second. Lambda is wavelength of light, this is wavelength of light. Please note it down. Last line I spoke, the energy of a quantum of radiation is proportional to its frequency. Now, till then there was a big problem कि we could not find out whether electron is a particle or it is a wave. When it is far away from the nucleus, it is behaving like a wave. When it is closer to the nucleus, it is behaving like a particle. So early researchers were very much confused whether we should treat it like particle or we should treat it like wave. So a man came with a very broad vision, Louis de Broglie. He said that let us say these particles as matter waves, and let us treat them like wave as well as like particle. People say that yes, we can treat them whenever required like a wave, whenever required like a particle, but there must be some interlinking point now. Since if same particle is behaving like wave, same particle is behaving like particle, so there must be some interlinking point. What is that interlinking point? Because to define the character of wave, you should know the frequency, you should know wavelength, like that. These are the attributes related with the wave. But to define the characters of a particle, you should know the momentum, how does it collide and how does the momentum changes. You should know the kinetic energy. So is there any linkage between the momentum, kinetic energy and wavelength and frequency? If it is, then we can use. So de Broglie proposed a relationship, and that relationship established the duality principle. Duality means this particle can behave like a wave as well as particle, right. So, let us see what de Broglie proposed and what is de Broglie's wave particle duality principle. Put next heading, wave particle duality, wave particle duality. Milu, its experimental value. Based on wave particle duality, based on wave particle duality, based on wave particle duality, Louis de Broglie proposed that particles of matter such as electrons could exhibit a wave character in certain experiments, a wave character in certain experiments, could exhibit a wave character in certain experiment. De Broglie proposed that de Broglie proposed that a particle of momentum P has wavelength given as lambda is equal to h by p. It can also be written as h by mv. Here lambda is de Broglie wavelength. h तो आप जानते हैं, p is momentum, m is mass, v is velocity, right. So please note down these things. ये इंजीनियरिंग सर्विसेज 20 में किसी ब्रांच की मटेरियल साइंस में पूछा गया है, so it may be asked again also, this relationship. So if you know the wave character, means you know the wavelength, then you can calculate the particle character. If you know the particle character, then you can calculate the wavelength. So this relationship is basically the interlinking point. It is the interlinking point. रमन यार डिक्टेट तो मैं भी करना चाहता हूं, बट इतने लोग मैसेज लिखते हैं, लगते हैं लास्ट लाइन, पहली लाइन, दूसरी लाइन की, इट इरिटेट्स एक्चुअली। सो मैंने सोचा उससे अच्छा लिख ही दिया करूं। चाय कैसी है बताओ? हाउ इज द टी? Written? Good. Now let us talk about Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. I am writing it in mathematical form only, not in theory. That's sufficient. He said that for a moving particle, simultaneous measurement of position and momentum accurately is not possible. So he have given a mathematical relationship, delta p dot delta x must be greater than or equal to h by 4 pi. This is Heisenberg's uncertainty principle. Here delta p is error in measurement of, error या अनसर्टेनिटी, जो भी कहना चाहें आप, अनसर्टेनिटी, अनसर्टेनिटी या एरर इन मेजरमेंट ऑफ मोमेंटम, measurement of momentum. Delta x is uncertainty या error in measurement of position. बहुत बढ़िया, गुड, एंजॉय करिए चाय। कोई कह रहा जीभ ना जल जाए, नहीं नहीं, बड़ा अनुभव है हमें चाय पीने का, जीभ नहीं जलेगी। It means there must be some error in the measurement of position as well as momentum. So what the Bohr is saying that if it is a nucleus, then at this point there must be an electron. These points are what? Orbits. So he is saying that there must be an electron. This man Heisenberg is saying that कि नहीं जी, precisely कह पाना मुश्किल है. Electron can be below this point, can be above this point. So one big implication of Heisenberg's uncertainty principle is that we cannot precisely say that at this point there must be an electron. If we cannot talk about precise position, then we should talk in terms of probability. So the big implication of Heisenberg's uncertainty principle is that we should talk in terms of probability distribution. At this point, what is the probability of finding electron? Maybe at the orbits probability would be higher, before the orbit probability will be lesser, above the orbit probability would be lesser, then at the next orbit probability will again become higher. So rather than talking about the fixed position of electron around the nucleus, let's talk in terms of probability distribution of the electron. Means around the nucleus you talk in terms of some probability function. Since atom is a spherical body, so we need to talk about probability per unit volume, and this probability per unit volume is known as probability density function. So I am going to dictate this line, what I told you, what is the implication of Heisenberg's principle. You please write down. यहाँ लिखिए एक line. Sugar is little less. Yes, sugar is little less because I took tea of less sugar. Why call it duality? Why not non-duality? अरे it's not non-duality in Abhishek. Dual है. Dual means double behavior show कर रहा है. Either like a wave or like a particle. So it's dual. नॉन ड्यूअल का मतलब तो हुआ एक ही बिहेवियर। जैसे हम तुम कभी भी वेव की तरह बिहेव नहीं करते, हम तुम कैसे बिहेव करते हैं, हमेशा पार्टिकल की तरह। सो वी आर नॉट नॉन ड्यूअल, वी आर नॉट डुअल, वी आर नॉन ड्यूअल। Please note down one or two lines related with Heisenberg's uncertainty principle. One implication of uncertainty principle is that we cannot properly speak of the position of an electron, speak of the position of an electron speak of the position of an electron. Instead we must look for the probability of finding electron. We must look for the probability of finding electron at a certain position, around the nucleus. Hence we can develop a probability density function to describe the distribution of electron in an atom around the nucleus. Full stop. अखिलेश बेटा वही तो लिखा रहा हूं कि व्हाट डज हीजनबर्ग अनसर्टेनिटी प्रिंसिपल सिग्निफाई। ये सिग्निफाई कर रहा है कि अभी तक के जितने भी मॉडल हमने बनाए उन सभी मॉडल में हमने क्या कहा कि इलेक्ट्रॉन किसी पर्टिकुलर ऑर्बिट में पाया जाएगा, लेकिन ये कह रहा है कि हम इलेक्ट्रॉन के बारे में प्रिसाइजली बता ही नहीं सकते हैं क्योंकि वो मूव कर रहा है। तो अगर हम प्रिसाइजली बता ही नहीं सकते तो कैसे कह सकते हैं कि किसी ऑर्बिट में पाया जाएगा? वो हो सकता है ऑर्बिट से थोड़ा पहले हो या ऑर्बिट से थोड़ा बाद हो। सो रादर देन टॉकिंग अबाउट लाइक दिस कि इलेक्ट्रॉन शुड बी फाउंड इन अ ऑर्बिट, वी शुड बी टॉकिंग अबाउट प्रोबेबिलिटी ऑफ फाइंडिंग इलेक्ट्रॉन, बिकॉज वी कैन नॉट टेल विद सर्टेनिटी अबाउट द पोजीशन ऑफ इलेक्ट्रॉन, राइट। सो वही चीज लिखा है हमने। आइए, by using Heisenberg's uncertainty principle, we developed the modern concept of atomic model, जो आज तक फॉलो हो रहा है। मॉडर्न कंसेप्ट ऑफ एटॉमिक मॉडल। This is also known as wave mechanical model of atom. Wave mechanical model of atom, sometimes also known as electron cloud model of atom. In this model, we do not consider the electron as a particle, rather we consider it as a wave as well as a particle. So we do not talk about precisely at this position there would be electron. Instead we say that beyond the nucleus there would be certain probability of finding an electron. For example, you see, let us suppose this is the nucleus. Suppose we have this nucleus. You please put the heading, I have to take it up. जी www, आपका नाम www आ रहा है, बिल्कुल सही कह रहे हो आप, कुछ ऐसा ही बिहेव कर रहा है. आइए जरा देखिए, एक्चुअली पाया ये गया कि लेट अस सपोज ये न्यूक्लियस है, सपोज, एंड हम इलेक्ट्रॉन की एनर्जी को प्लॉट करें. दिस इज एनर्जी ऑफ इलेक्ट्रॉन. राइट. अब अगर हम इस एनर्जी को प्लॉट करें तो बोहर चाचा के हिसाब से यू वुड बी गेटिंग फर्स्ट ऑर्बिट, एंड फॉर द फर्स्ट ऑर्बिट द एनर्जी इज हाउ मच, -13.56 electron volt. This is for n is equal to 1. Then for the second orbit n is equal to 2, you are getting energy that is -3.39 electron volt. Then for the third orbit n is equal to 3, you are getting energy and that is -1.51 electron volt. Likewise you keep on moving, इसी तरह से आप बढ़ते चले जाएंगे. ठीक. But in the modern concept we saw that these orbits are further divided in subcell. इन्हें हम क्या कहेंगे, सेल, ऑर्बिट या सेल, एंड दीज सेल्स आर डिवाइडेड इन सबसेल्स. फर्स्ट सेल तो सिर्फ एक ही है, 1s, but the second one is having two energy level, 2s and 2p, and then 2p is further divided in 3 states. Similarly 3s is divided in 3 energy states. These are 3s, 3p and 3d. So there is something like subcell also in the cell. Now if I take this concept, then electron can be on either this energy state or this energy state. So we cannot say precisely that electron is at this point, which Bohr was saying, because Bohr was not knowing about the subcells, he was knowing only about the cells. So if I include the Heisenberg's uncertainty principle, then I can divide the cell into subcells also, and we can say that the electron can be either at this location or it can be at this location. So let's talk about probability of finding electron in the second orbit, not the exact position of the electron. Similarly, out of these 3 positions, electron can be at anywhere. It can be at this location or this location. So this concept help us to classify cells into subcells and then further the subcells into the energy states like that. So here comes the picture where we have to talk about the position of electron in terms of probability, not surety, because third cell means it can be in all these positions, इनमें से किसी में भी हो सकता है, जबकि Bohr was saying that fix यही होना चाहिए. So he was not knowing exactly how the electron is moving around the nucleus. He was not knowing about the subcells. He was knowing only about the cells. You see, my dear friend, if we represent it further diagrammatically, then I can say that, okay, let us suppose this is our atom. Let us suppose I am making the first orbit only, just for the explanation purpose, and this is the nucleus, right? This is the nucleus and this is our first orbit. So let us try to figure out the probability of finding electron from the nucleus. I am wanting to plot the probability of finding electron. This is distance from the nucleus. This is distance from the nucleus. This is distance from the nucleus. And now here we are wanting to find out probability of finding electron. So at this axis we have probability. In the same diagram I am representing both. This is n is equal to 1 and this is. So according to the Bohr's model, there must be some electron here. So must be means the probability of finding the electron is 1. This value must be 1 according to the Bohr's model. This diagram is representing Bohr's model, this side. There must be an electron in this position. But according to the wave mechanical model, this cell can be divided in subcell also. So electron can be in the subcells. Suppose it is third cell, so 3s, 3p, 3d like that. So electron can be either before it or at this position. So if I talk about the probability of finding electron in this model, then it should not be exactly 1. It should be like this. From here the probability increased. As we are at the nucleus, the probability is 0. As we are moving away from the nucleus, we are getting certain probability of finding electron. As we reach to the orbit, we will have highest probability, and then the probability of finding electron will keep on decreasing like this. So this distribution will show the probability of finding electron. So this is our wave mechanical model. Wave mechanical model. Here we are not sure whether it is in the first cell or second cell, whether it is in the first subcell or second subcell, or where either it is in S or it is in P or it is in D. So within a cell there are subcells, so we have to consider those subcells also. Although Bohr was not knowing about the subcells, so he said that there must be an electron. So according to the Bohr model, at this position there must be electron, so probability is 1. But according to the wave mechanical model, as we move away, the probability will keep on increasing, then it will reach maximum at the cell, and then it will keep on decreasing as we go away from the cell. This is actually the comparison between these two models for the finding electrons. So please you draw these two models, and then I would be dictating few points, and then we would be going further some mathematical relationships also. written? ये भी बनाइए। यस प्रतीक। Yes, probability diagram is there, you see it. Done? Please note down few points. Write down few theory. In this model, the electron is considered in this model, the electron is considered to exhibit both wave-like and particle-like characteristics. 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 Full stop. With this model, an electron is both wave-like and particle-like characteristics, full stop. With this model, an electron is no longer treated as a particle. An electron is no longer treated as a particle moving in a discrete orbital. An electron is no longer treated as a particle moving in a discrete orbital. Rather, rather, position is considered to be probability of an electron's position is considered to be probability of an electron's being at various locations around the nucleus. In other words, position is described by a probability distribution. Or electron cloud. भाई हीजनबर्ग डुअलिटी को ही सपोर्ट कर रहा है, आल्सो वाली क्या बात है अखिलेश जी? It is supporting the duality principle. friend, you see electrons are in motion, and if any particle is motion, then for its motion an equation can be developed. So Schrodinger developed a equation to describe the motion of electron around the nucleus, and that equation will give you the distribution of electron. So you need to write one line. The electrons in an atom are in continuous motion around the nucleus. The electrons in an atom are in continuous motion around the nucleus. So we can express the motion of electron. In the force field of nucleus, by Schrodinger wave equation, So we can express the motion of electron in the force field of nucleus by Schrodinger wave equation. What is this equation? This equation says that del square psi plus 2m upon h bar ka square, E minus V into psi is equal to 0. This equation is known as Schrodinger wave equation. This equation is known as Schrodinger wave equation. इस इक्वेशन को हम लोग नाम दे रहे हैं Schrodinger wave equation. Here psi is known as wave function. It is a mathematical function. We are not interested in this. Magnitude of psi square is function of x, y, z, and x, y, z are nothing but the position. So basically magnitude of psi square will tell us the distribution of electron around the nucleus. That is probability density function of electron around the nucleus, M is mass of electron, H, E is total energy of electron, V is potential energy of electron, and H bar is H by 2 pi. This H bar is known as reduced Planck constant. You all may be knowing this much of the mathematics, that this del square psi is nothing but del 2 psi del x2 plus del 2 psi del y2 plus del 2 psi del z2. It means equation 1 is a second order differential equation, and if we solve equation 1, then we would be getting psi, and that psi is nothing but the function of x, y, z. So magnitude of psi square, if plotted by assuming nucleus at the center, then it will give us the distribution of electron around the nucleus. Let us suppose we solve for the first orbit, then we would be getting the equation for a sphere. It means first orbit electrons are moving in a spherical volume around the nucleus. So solution of this equation is going to give us the position of electron. XYZ means position of electron around the nucleus. But my dear friends, this equation can have infinite solutions. किसी भी second order equation को solve करो, you will be getting two constants, and the value of constants will depend upon the boundary conditions. So you keep on changing the boundary conditions, you would be getting the infinite solutions. So which would be the acceptable solution for us? It's not possible that the same electron will have different path. No, in a particular atom, one electron will have a fixed path. So it means we need to find out some condition to solve this equation. So there comes a great scientist, Pauli. Pauli says that no two electrons can have all the four quantum numbers same. किन्हीं दो इलेक्ट्रॉन की चारों क्वांटम नंबर सेम नहीं हो सकती. In any atom, no two electrons can have all the four quantum numbers same. Or in other words, each electron will have different set of quantum number. In any atom, each electron will have different set of quantum number. So if I use these quantum numbers to solve this equation, then I will get unique solution for that electron. जिसकी क्वांटम नंबर यूज करेंगे उसी के लिए सॉल्यूशन पाएंगे. एंड दिस वे इफ आई प्लॉट दैट कर्व, then I would be getting the position of electron around the nucleus for that particular electron. So for each and every electron we need to solve this equation, and while solving this equation, as a boundary condition we should use the quantum numbers for the electron. Basically quantum numbers are the address parameters to denote the address of electron around the nucleus. For example, this whole India is an atom and Delhi is the center of this atom. You people are the electrons. So to locate you, we need certain parameters. First parameter, in which state you live. Second parameter, in that state in which district you live. And third parameter, in that district what is the post office. And fourth parameter, what is your house number. Similarly, to locate an electron, we also need four parameters. First, in which cell it is, and then second, quantum number will tell you ki in which subcell it is, and the third quantum number will tell you ki in which energy state it is, and the fourth quantum number will tell you ki how it is moving, anti-clockwise or clockwise, what kind of spin it is having. So these four parameters are just like address, just like postal address for the electron. So if I use those postal address to solve this equation, then I would be getting the exact solution for that particular electron, and this way the modern concept of atomic model deals with the position of electron around the nucleus. So you please note down this, then I would be dictating this thing. इसे equation 1 कह दीजिए, please note down it. Noted? लिखें the solution of equation 1, the solution of equation 1 the solution of equation 1 give distribution of electron around the nucleus, give distribution of electron around the nucleus. around the nucleus. Full stop. Equation 1 can have equation 1 can have equation 1 can have many solutions, many solutions, many solutions, but the physically meaningful and acceptable solutions are obtained. Acceptable solutions are obtained, but the physically meaningful and acceptable solutions are obtained. Only when the electrons are permitted to have specific values of energy. Only when the electrons are permitted to have specific values of energy. Full stop. These allowed values of energy, these allowed values of energy these allowed values of energy or the allowed electron states, the allowed electron states in an atom are specified by the solutions in terms of four parameters, known as quantum numbers, Meelu Jan is saying that PSI is something like special potential. Dear Meelu, if I do remember, you were in my EDC class also. There I have discussed in depth about this wave function. Please visit your notes, right? Here it's not possible to discuss so much about this wave function. So briefly I am taking it from GS point of view, general studies point of view. You please refer your notes. There I have discussed in depth about the wave function. Right. So I said that quantum numbers are the parameters which help us to solve this equation in order to determine the position of electron. So let's talk about quantum numbers. Quantum numbers. Using wave mechanics या wave mechanical model, using wave mechanical model of atom, every electron in an atom is characterized by four parameters, called quantum numbers, numbers. The size, shape and spatial orientations, the size, shape and spatial orientation of electrons probability density function, probability density function, the size, shape and spatial orientation of electrons probability density function is specified by three of these quantum numbers, is specified by three of these quantum numbers. Actually, fourth quantum number tells us only about the spin of electrons. So, to locate an electron in three-dimensional space, only three quantum numbers are sufficient. First three are sufficient. The fourth one will tell you either anti-clockwise or clockwise. So, it is not talking about the location, it is just talking about the spin of the electron, anti-clockwise spin or clockwise spin. So, sometimes they used to ask to locate an electron in three-dimensional space, minimum how many quantum numbers are required. So, minimum 3 quantum numbers are required to locate an electron in three-dimensional space, right. First quantum number, let us go for the first quantum number. First quantum number, it is represented by n. It is represented by n, also known as principal quantum number. Principal quantum number. It is also known as principal quantum number. Principal quantum number. First quantum number is also known as principal quantum number. इसकी वैल्यू होती है n इज इक्वल टू 1 से शुरू होगी, 1 2 3 4 up to so on infinity तक. This quantum number is related to the distance of an electron from the nucleus. Basically, it will tell you about the orbit. So, this quantum number represents cell. Yes, cells are specified by this quantum number. Cells are specified by this quantum number. So, basically it is telling you how much distance is electron having from the nucleus. Cells are denoted as K, L, M like this. First cell K, second cell L, third cell M like that. So, it will give you rough idea about the distance of electron from the nucleus. So, next one is this quantum number is related to the distance of an electron from the nucleus. This quantum number is related with the distance of an electron, This quantum number is related with the distance of an electron from the nucleus. Distance of an electron from the nucleus. You see, my dear friend, this point, either in first cell or second cell. So, basically it is giving you distance of electron from the nucleus, right. It is the only quantum number regarding which Bohr were knowing. Sorry. So basically this quantum number is related with the Bohr's model. It represents cells. Remaining other things Bohr were not knowing. He was not knowing about 3s, 3p, 3d, means he was not knowing about subcells. So sometimes they used to ask which of the following quantum number is related with the Bohr's model. So only the principal quantum number is related with the Bohr's model, because Bohr was knowing about the cell, he was not knowing there are subcells, there are energy states and all those things. So you can write this point also. This quantum number is associated with the Bohr's model. This quantum number is associated with the Bohr's model. Bohr's model. This quantum number is associated with the Bohr's model. So this is about the first quantum number. Please note it down quickly. Yes, orbit and cell both are same thing. Pratik has. Next point. Second quantum number. Second quantum number. It is denoted by L. It is also known as angular or azimuthal quantum number. It is also known as angular or azimuthal quantum number, also known as azimuthal quantum number. It signifies the subcells. It signifies the subcells. What are subcells? Subcells are S, P, D, F. So second quantum number signifies subcells. Basically, it is related with the shape of the subcell. It is related with the shape of subcell. The number of these subcells is restricted by n, yani by the principal quantum number. The number of subcells are restricted by the magnitude of n, by the magnitude of n. That is, L की जो वैल्यू होगी that is 0 to n minus 1. What does it signify? It signifies that, let us suppose n is equal to 1. So n is equal to 1 के लिए L is equal to 0 and L is equal to 0 represents S subcell. So in the first orbit you will have only one subcell, that is S. But suppose n is equal to 2, then L will have two values, L is equal to 0 and L is equal to 1, because 0 to n minus 1. So n minus 1, 2 minus 1. 0 is representing S and 1 is representing P. So L is equal to 1 value represents P subcell. Similarly, suppose you have N is equal to 3. So L will have 0, 1, 2, 3 values, right? So 0 is representing S, 1 is representing P, and 2 is representing D. Suppose N is equal to 4, you go for the fourth subcell. So fourth cell, not subcell. So for the fourth subcell, you have L is equal to 0, 1, 2, 3, N minus 1. So 0 represent S subcell, 1 represent P subcell, 2 represent D subcell, 3 represent F subcell. So this way you will keep on proceeding. So N is equal to 1 is representing that we have only one subcell, that is S subcell. N is equal to 2 represents we have 0 and 1, basically 2 subcells. 3 represents we have 3 subcells. 4 represents we have 4 subcells, likewise. So the value of L, value of the second quantum number, depends upon the first quantum number, that is N. Please note it down. Adarsh ji, I belong from Uttar Pradesh. There is a place Amethi in UP, so I belong from that district. If N is equal to 5, Pratik is writing if N is equal to 5, then you will have one more subcell, that is G. ठीक, although अभी तक जितने एलिमेंट हैं उनका इलेक्ट्रॉनिक कॉन्फ़िगरेशन is only up to the F subcell, but suppose you get a new element N which is having higher atomic number, then you need further subcells. So N is equal to 5 के लिए L will become 4, and for that you can write G. Suppose N is equal to 6, so for that you can write H. So this you can keep on up to. Next, third quantum number. Third quantum number. It is represented by ML, also known as magnetic quantum number. Also known as magnetic quantum number. Magnetic quantum number. Also known as magnetic quantum number. The number of energy states, the number of energy states in each subcell, the number of energy states in each subcell is determined by third quantum number, is determined by third quantum number. Is determined by third quantum number. There are 2L plus 1 values. There are 2L plus 1 values of ML ranging from minus L to plus L. What does it mean? It means that, let us suppose you talk about S subcell. Suppose you are talking about S subcell and you are wanting to know how many energy states are in S subcell. Energy states are basically those positions where electron can be found, because energy state means the state which has some energy, and energy will be not of the state, it will be of the particle. So basically it is the position where particle would be found. So S, for S, L is equal to 0. So number of ml is how much? Number of ml is 2 into 0 plus 1, that is 1. So S subcell will have only one energy state. So it will have one energy state, one energy state, जिसको आप वैल्यू दोगे ml is equal to 0, minus L to plus L. So minus 0 or plus 0 both are same. Let us suppose you talk about P subcell. So in the P subcell you have L is equal to 1. For L is equal to 1 denotes P subcell. So number of ml is how much? Number of ml is 2 into 1 plus 1, that is 3. It means P subcell has 3 energy states. 3 energy states. How can you name them? So let us suppose this is P and this is having 3 energy states. So they are from minus L to plus L. So L is how much? 1. So ml is equal to minus 1, ml is equal to 0 and ml is equal to plus 1. So 3 values, minus 1, 0 and plus 1. When there is no magnetic field, all these 3 states are at the same energy. But if you apply magnetic field, they will slightly differ in energy. That's why it is known as magnetic quantum number. In the absence of any external magnetic field, all these 3 states, minus 1, L and 0, they are at the same energy level. But as soon as you apply magnetic field, their energy will slightly differ. That's why they are known as magnetic quantum number. Similarly, suppose you talk about P subcell. So for the P, what we have D for D, L is equal to 2. So L is equal to 2 means number of ml is equal to 2 into 2 plus 1, that is 5. So it means D has 5 energy states. D has 5 energy states. What would be the value of these 5 energy states? The value of these 5 energy states are like this: 1, 2, 3, 4, 5. So it would be minus 2, minus 1, 0, plus 1 and plus 2, right? Let us suppose we go for the F subcell. So for F subcell, L is equal to 3. So if L is equal to 3, number of ml is 2 into 3 plus 1, that is 7. So it means in the F subcell you are having 7 energy states. 7 energy states. How will you name them? You will be naming from minus L to plus L. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it is minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Likewise. So this, how many energy states are in a subcell? This we get information from the third quantum number. Please note it down. ढेर सारा आशीर्वाद मनोज, पढ़ाई करते रहो. Please note down quickly. Good. Write down one thing. In the absence of magnetic field, in the absence of magnetic field, yeah, basically the better word would be external magnetic field. In the absence of external magnetic field, external magnetic field. External means applied, which we are applying. So, in the absence of external magnetic field, the states within each subcell are identical. The states within each subcell are identical. Within each subcell are identical. The states within each subcell are identical. However, when a magnetic field is applied, when a magnetic field is applied, when a magnetic field is applied, these subcell states split. However, when magnetic field is applied, these subcell states split, each having slightly different energy. Split, each having slightly different energy. Each having slightly different energy. Please note down. ml की वैल्यू 0 लिखा है मैंने, नंबर ऑफ ml1 आएगा, जो वैल्यू ml को देते हैं वो -L to L देते हैं, ये जैसे -1 0 +1, तो उसी तरह से L = 0 के लिए क्या देंगे, -0 +0, -+0 का कोई सिग्निफिकेंस नहीं, दैट्स व्हाई आई एम रिटन 0। कहाँ रहते हो यार तुम लोग, भांग खाते हो क्या? सुबह सुबह लगा लेते हो एक गोला, आ जाते हो, कुछ भी समझ में आता नहीं है। तो तुमको ये सब नहीं समझ में आ रहा है तो आईसीटी कैसे पढ़ते होगे, करंट अफेयर्स, एनवायरनमेंट, वो सब तो और भी ज़्यादा थ्योरी है, यहाँ तो थोड़ा बहुत साइंस है। डन। आइए फोर्थ क्वांटम नंबर, fourth quantum number. It is represented as ms, also known as spin quantum number, also known as spin quantum number, spin quantum number. Actually, electrons spin at their position. Spin means like this kind of motion without changing its position, the circular motion, the angular motion. So at a point position there can be two types of spin, one anti-clockwise and other clockwise. So let us suppose anti-clockwise is said as upward, then clockwise is downward. So if you take upward direction as positive, then downward direction would be considered negative, or you take upward direction as negative, then the downward direction would be positive. So basically we can have two spin quantum number, one related with the upward direction and other related with the downward direction. So this fourth quantum number is not telling you about the position. Up to this position we have reached with the help of first three quantum numbers. Fourth one is just telling about anti-clockwise or clockwise motion of the electron. That's why in the beginning I said that only 3 quantum numbers are required to tell you the position of the electron, the shape, size and distribution of electron that can be determined by the first 3 quantum numbers. Fourth one will tell you just only one thing, either anti-clockwise or clockwise, nothing more. So electrons can have a spin, electrons can have a spin either anti-clockwise or clockwise Hence we have spin quantum numbers as spin quantum numbers as ms plus half, suppose for anti-clockwise, then minus half for clockwise. So we can have only 2 choices for the spin quantum number. Now one very important thing, Pauli said that for each electron there should be different set of quantum number. So let us suppose I talk about n is equal to 1. Let us suppose there is an electron at n is equal to 1. So at n is equal to 1, first quantum number, then L should be equal to 0, ML should be minus L to L, that is 0. Then MS has 2 values, 1 plus half, let us suppose for anti-clockwise, and then minus half for clockwise. It means we have 2 electrons at this position. N is equal to 1 is denoting what? 1s. So in the 1s we can have 2 electrons, and for them the quantum numbers are like this. Now you see, both of them are having different set of quantum number. For the first one you have 100 and plus half, and for the second one you have 100 minus half. So if you want to know about the first electron, then use these quantum numbers as the boundary condition to solve the Schrodinger wave equation. Whatever solution you get, that will represent the first electron of the first orbit. If you use this as boundary condition, then whatever solution you will get, that will represent the second electron around the nucleus. So same thing is Pauli is trying to say that no 2 electrons can have all the 4 quantum numbers same. It means each electron will have different set of quantum number. इसका मतलब ये भी हुआ कि किसी एक एनर्जी स्टेट पर एट मैक्स 2 इलेक्ट्रॉन हो सकते हैं, एक एंटी क्लॉकवाइज और एक क्लॉकवाइज. एंटी क्लॉकवाइज यू कैन रिप्रेजेंट लाइक दिस एंड क्लॉकवाइज यू कैन रिप्रेजेंट लाइक दिस. सो एंटी क्लॉकवाइज लेट अस सपोज प्लस हाफ, then clockwise it would be minus half. So there cannot be more than 2 electrons at a particular state, right? So इस बात को थोड़ा सा और elaborate करते हैं और इसको लिखते हैं in terms of Pauli's exclusion principle. Pauli's exclusion principle. वेरी गुड. आईसीटी वाले सर हिंदी में समझाते हैं, बहुत अच्छी बात है. तो अंग्रेजी वाले रो रहे होंगे. आधी क्लास तो हमेशा रोएगी, कोई बात नहीं. तो छोड़ो मटेरियल साइंस, आईसीटी पढ़ लो, आईसीटी पढ़ लो. एंड दोज सब्जेक्ट्स व्हिच आर इन हिंदी, रीड दोज सब्जेक्ट्स. कौन सा 100 में 100 लाना है? देखो, टीचर पे गुस्सा हो करके, चाहे वो सौरभ सर हो या मैं हूं, या कोई फायदा नहीं, क्योंकि टीचर विल बी टीचिंग इन ओनली दैट मीडियम व्हिच वुड बी टोल्ड बाय द मैनेजमेंट. Please note down. This principle states that this principle states that this principle states that each electron state can hold no more than 2 electrons, no more than 2 electrons, which must have opposite spin, spins. This principle is trying to say that at a particular state there can be at max 2 electrons, but both of them must have opposite spin. Means if one is anti-clockwise, other must be clockwise. Same principle can be written like this. In any atom, no two electrons can have all the 4. In any atom, no 2 electrons can have all the 4 quantum numbers to be same. That is, each electron will have a different set of quantum number. Each electron will have a different set of 4 quantum numbers. In any atom, no 2 electrons can have all the 4 quantum numbers to be same. Each electron will have a different set of quantum number. You see, my dear friend, here it is the first electron. This has 1 0 0 and plus half, one set, and it is the second electron of the s orbital. It has 1 0 0 and minus half. So all the 4 quantum numbers are not same. In the worst possible case, first 3 can be same, but fourth one must differ, right? So what I am wanting to tell you indirectly, that at a particular energy state we can have only 2 electrons. So let us have a direct consequence of this effect. The direct consequence of this effect is in the S cell there is one energy state, and if there is one energy state, then at max 2 electrons. So S subcell cannot accommodate more than 2 electrons, one anti-clockwise and another clockwise. Then P subcell is having 3 energy states. So at one energy state 2 electrons. So at 3 how many? At max 6 electrons. So P subcell cannot accommodate more than 6 electrons. इसी तरह से D is 5 energy states. So 5 energy states means what? At max 10 electrons. So D subcell cannot accommodate more than 10 electrons. And F, so F has 7 energy states. What does it mean? It means at max it can have 14 electrons, not more than that. So D subcell cannot accommodate more than 14 electrons. F subcell cannot accommodate. So this way each subcell will have a certain capacity to hold the electrons. and it cannot hold more than this. बेटा शुभम, वहां पर हम स्टेट को एंटी क्लॉकवाइज को एक स्टेट मानते हैं और क्लॉकवाइज को दूसरी स्टेट मानते हैं। यहां हम दोनों को, जिनको एक स्टेट कह रहे हैं, ईडीसी में उनको हम सेपरेट कर देते हैं स्प्लिटिंग की वजह से। एंटी क्लॉकवाइज इज अ सेपरेट स्टेट एंड क्लॉकवाइज इज अ सेपरेट स्टेट। तो अगर उस पॉइंट ऑफ व्यू से उन दोनों को अलग अलग स्टेट मान लो तो एक स्टेट पर एक ही इलेक्ट्रॉन होगा। लेकिन अगर दोनों को एक ही स्टेट मान रहे हो कि एक एंटी क्लॉकवाइज उस पर होगा और एक क्लॉकवाइज होगा, तो फिर एक स्टेट पर दो इलेक्ट्रॉन होंगे। सो इट्स ऑल अबाउट द एजम्पशंस कि वेदर यू आर एज्यूमिंग स्टेट as a position where you can have anti-clockwise and clockwise both, then एक स्टेट पर दो इलेक्ट्रॉन हो सकते हैं। लेकिन अगर आप किसी स्टेट को सिर्फ एंटी क्लॉकवाइज या सिर्फ क्लॉकवाइज लेकर के चल रहे हो तो एक स्टेट पर सिर्फ एक ही इलेक्ट्रॉन हो सकता है। तो आप जरा वो जिस चीज की बात कर रहे हो ईडीसी में, वहां आप देखिए कि हम ये मान करके चलते हैं कि एक स्टेट पर एक ही इलेक्ट्रॉन हो सकता है। इसका मतलब या तो एंटी क्लॉकवाइज या क्लॉकवाइज, दोनों पॉसिबिलिटी नहीं है। यहां हम दोनों पॉसिबिलिटी बता रहे हैं कि एंटी क्लॉकवाइज भी और क्लॉकवाइज भी। ठीक, पूरा सुना करो यार, इतना ढंग से कवर किया गया है फिर भी तुम लोग कंफ्यूज हो जाते हो। प्रतीक, मुझे पता नहीं है कि ये क्वांटम नंबर किसने प्रपोज किया है, स्पिन क्वांटम नंबर, क्योंकि मॉडर्न फिजिक्स में एक ही समय पर बहुत सारे लोग रिसर्च कर रहे थे, सो नाम बहुत कम ही मिलता है। एक्चुअली जो मॉडर्न कंसेप्ट ऑफ एटॉमिक मॉडल है वो किसी एक व्यक्ति को क्रेडिट नहीं दिया जाता है। It includes de Broglie's duality principle, Heisenberg's principle, then Sir Faggot Thomson, J.J. Thomson के बेटे थे, उन्होंने भी कुछ contribution दिया था। Summerfield has given some contribution because of which elliptical path of the orbit is determined, subcell is determined. So there are several scientists who get involved in development of this modern concept of atomic model. So I don't remember who has proposed the idea behind the spin quantum number. In fact, honestly speaking, I have not read who has proposed it. Is that clear to everybody? Shall we go ahead? My dear friend, if I write in terms of cell, because number of cell will decide how many subcells are there. So we can write this whole explanation in terms of cell also. For example, if n is equal to 1, then only one, S subcell, and in the S subcell there can be only 2 electrons. But n is equal to 2, you will have S and P, so at max 2 plus 6, at max 8 electrons. N is equal to 3, you will have SPD, so you can have 18 electrons. So we can write this in an nth cell. There can be at max 2n square electrons. In an nth cell, there can be at max 2n square electrons. Means what? N is equal to 1. So at max 2 electrons. 2 electrons. Then n is equal to 2. At max 8 electrons. At max 8 electrons. N is equal to 3, then at max 18 electrons. N is equal to 4, then at max 32 electrons. Likewise, you keep on moving. So as the number of cell is increasing, the number of electrons will be increasing. So first cell can contain at max 2 electrons, second cell contain at max 8 electrons, and third cell contain at max 18 electrons, fourth cell contain at max 32 electrons. But there is an exception to this rule. That exception says that the outermost cell of any atom cannot accommodate more than 8 electrons. What do I want to say? If n is equal to 4 is inner cell, then it can have at max 32 electrons. But if it is outermost cell, then it cannot have more than 8 electrons. So we can write it like this. There is an exception to this rule. there is an exception to this rule, exception to this rule, that is the outermost cell cannot accommodate more than 8 electrons. More than 8 electrons. The outermost cell cannot accommodate more than 8 electrons. इसे हम लोग octet rule कहते हैं. Very important rule. What we have observed that the elements which have 8 electrons in the outermost cell, they are the most stable elements. And my dear friend, you must know stability and energy are inversely proportional. It's universal for everything, even for me and you, for everything. If we are stable, our energy will be minimum. And if our energy is minimum, we are almost inert. We will not be active. But if we are unstable, our energy would be high. And if our energy would be high, we would be doing some activity. We would be doing some activity to spend our energy so that we can get stability. So everything which is unstable, it is always trying to do something to achieve the stability. Stability for the atoms will come when it will have 8 electrons in the outermost orbit. इसी stability को पाने की चाहत में it will do several activities, and in what kind of activities the atom is participating, that will define the property of the material, the property of the element. For example, suppose I am an atom. If I would have been stable in my life, then I would not be teaching you today. Suppose stability comes from money, and let us suppose I have abundance of money, then I will not be coming to teach you. I would be inert at my home, बैठे हुए मैं सो रहा होता. I would not be active. But very early in the morning, I wake up, I get prepared, dressed up, and I came to you to teach you because I don't have sufficient money. So I want to achieve that money in order to get stability. And to get stability, I am performing certain job. It means I am participating in certain activity, and that activity is teaching. So what is my character? My character is I am a teacher. Same happens with the atoms. If atom is stable, its octet is complete, it will not participate in any kind of activity. So it will be considered as inert one. But if its octet is incomplete, so in order to complete the octet, it will participate in any activity. And in what kind of activity the atom is participating, that will decide the character of the atom. कि ये teacher है, कि चोर है, कि student है, क्या है? That will decide the character of the material. एटम का जो करेक्टर होगा वैसे ही मटेरियल का भी करेक्टर आएगा, क्योंकि मटेरियल इज मेड अप ऑफ द एटम्स. So this octet is basically the foundation stone behind the properties of the material. कि how does an atom is trying to complete its octet, that will decide in what kind of activity it is participating. For example, to complete to get stability, some people are studying, they will be known as a student. To get stability, some people are doing job in the bank, so they are the bankers. Some people like me, to get stability, are teaching, so they are the teachers. Some people are in politics to get the money, so they are politicians. Some people are doing acting to get the money, so they are the actors. So there are different ways to get the stability. Ultimate aim is to get the stability, but there are different ways to get the stability, and in what way one is getting stability, that is going to decide the character. So same thing happened with the atoms, कि the ultimate aim of every atom is to complete its octet, means they are wanting to get to get 8 electrons in the outermost orbit. So how they are completing their octet, in what kind of activity they participate to complete their octet, that is going to decide their character. And that is the matter of discussion in the subject. Why we are reading all these absurdities? Just to know the character of the material. So this point is very important, to know the character of the material. आइए देखते हैं. Let's have a rough overview of the periodic table, because all the atoms are over there arranged in the increasing order of their atomic number. I am not making the complete table, I am giving you the rough overview of the table. So first to 8th group, 6th, 7th and 8th. मॉडर्न पीरियोडिक टेबल में इसमें फर्स्ट ए फर्स्ट बी सेकंड बी लाइक दैट भी है, बट फर्स्ट ए एंड फर्स्ट बी विल हैव मोर और लेस सेम कैरेक्टर, सो आई एम नॉट बॉदरिंग अबाउट दैट. आई एम राइटिंग फ्रॉम फर्स्ट टू 8th ग्रुप. दिस इज द पीरियोडिक टेबल. नाउ हियर you have the first element, that is hydrogen, and the second element you have helium. Hydrogen atomic number is 1 and helium atomic number is 2. Then you have lithium, sodium, potassium, etc. अलीना ने किया रब से पर याद. Then बेटा मांगे कार स्कूटर बापरे. बाल गंगाधर इंडियन थे. Then काशी जी संतों की पगडंडी. Then नाइट्रोजन, फास्फोरस, आर्सेनिक. देन ओसामा से तेंदुलकर पाउडर मांगे. देन फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, एस्टेटीन एटसेट्रा. एंड देन हिनी और करिश्मा, जॉन टी रोड्स. Like this. My dear friend, leave hydrogen and helium, because hydrogen has only one cell. Helium is also having one cell. So in the first cell there can be at max 2 electrons. So for hydrogen there is no necessity to get 7 more electrons. If it get 1 more electron, it will become like helium and it will become stable. All these elements has their octet complete except helium. Forget about the helium. Neon, argon, krypton, xenon, radon, everyone is having 8 electrons in the outermost orbit. So octet is complete. Octet is complete. And if the octet is complete, so they are the most stable. And if they are most stable, energy is minimum. Energy is minimum. So they are chemically inactive. Chemically inactive. Chemically inactive means inert. That's why they are known as inert gases. And if they are inert, they will not participate in any bonding process, they will not participate in any chemical reaction, they will not participate in anything. But except this group, all other elements have incomplete octet. And if they have incomplete octet, they will try to complete their octet. For all the elements of this group, this row, इस रो के सभी एलिमेंट का आइडियल कौन है? नियॉन. All of them are wanting to become like neon. They are wanting to get electronic configuration like neon so that they will become stable. So in order to get the electronic configuration like neon, they will participate in a certain activity. They will try to bond with the neighboring atoms so that let's become like neon, let's become rich, let's become noble, let's become inert. So how they will participate in various processes, that is going to define their character. Similarly, for all these elements, the ideal one is what? Argon. So all of the elements, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, all of them are wanting to get configuration like argon. So how they are going to be like argon, that is going to decide their character. So now here onwards we have to discuss how the outer orbit octet of any element is becoming similar to the configuration of the nearby 8th group element, nearby the inert element. कैसे किसी एटम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन उसके पड़ोसी नोबल गैस के जैसा बन रहा है, उस ग्रुप के, उस रो के नोबल गैस जैसा बन रहा है। यही मैटर ऑफ डिस्कशन। यहां कुछ एक चीज है, आप देखेंगे ध्यान से, दिस फोर्थ ग्रुप इज एट द मिड ऑफ द पीरियोडिक टेबल। बीच वालों का करेक्टर आसानी से बताना बहुत मुश्किल होता है। बिफोर द फोर्थ ग्रुप either you have 1 electron or 2 electron or 3 electron. It means all these elements have very less number of electrons in the outermost orbit. So for them to get more number of electrons is very difficult. Suppose I say you have 110 rupees, but stability will come either you have 100 rupees or you have 200 rupees. So for you, getting 90 more rupees is very difficult. You will try to spend 10 rupees and will try to become stable. So all these elements which are in the first, second, third group, they have very less electrons in the outermost orbit. Let us suppose I talk about sodium. So sodium भाई साहब के पास कितने इलेक्ट्रॉन है? 11. So this is the sodium nucleus. In the first cell is having 2 electrons. In the second cell is having 1, 2, 3, 4, 5, 6, 7, 8, and in the third it is having only 1 electron. If it has to complete its octet, it needs 7 more electrons, but it is very difficult to get 7 more electrons. There is one more way to get complete octet. If it leaves this electron, so the outer orbit will become this one, and this orbit has complete octet. So it is just like this organ. So these all elements, first, second, third group, will try to give up their electrons, because for them it is easy to leave this electron, and hence their outer orbit will become this one, and this one is having same configuration as like this one. So all of them are having tendency to give up their electrons. So if they give up their electron, they will become a positive ion, and if they are becoming positive ion, such elements are known as electropositive elements. Electropositive elements. So first, second, third group elements have tendency to give up their electron, and hence they try to make positive ions. That's why they are known as electropositive elements. There is an exception, hydrogen. Hydrogen is not electropositive. Hydrogen in the first group, but it does not follow the character of the first group. Why? That I will discuss in the tomorrow's class. Leave it. Apart from this, you see here, all these elements of 5th, 6th, 7th group, they have abundance of electrons in the outermost orbit. For example, chlorine, 17 electrons. This is the nucleus of chlorine. First orbit 2 electrons, second orbit 1, 2, 3, 4, 5, 6, 7, 8, and the third orbit 1, 2, 3, 4, 5, 6, 7. It is very close to the octet. It will not try to give up its electrons. Suppose you have 190 rupees, and I say that stability will come either at 100 or at 200. What you will do? You will try to get 10 rupees, so that you can reach to the 200. So here chlorine is not trying to give the electron, because giving 7 electron is difficult rather than getting one more electron. So it will try to take one more electron. So since all these elements have tendency to take electron, once they take electron, they will become negative ion, and if they are becoming negative ion, they are known as electronegative elements. So all the elements which are in the 5th, 6th, 7th group, they are known as electronegative elements. Electronegative elements. Generally you will find that these electronegative elements are non-metals, whereas electropositive elements are metals. Electronegative elements, these are electronegative. रही बात fourth group की, so fourth group will have very different kind of character, and as well as hydrogen. So उनको इस electropositive या electronegative में categorize कर पाना मुश्किल है. इनकी बात कल किया जाएगा, क्योंकि ये बीच में है और बीच वालों का character आप इतनी आसानी से नहीं बता सकते हो. पुनीत उपाध्याय जी कह रहे हैं कि बात पैसे की आती है तो हम 90 रुपए और लेना चाहेंगे. आप तो चाहोगे कि 90 मिल जाए, लेकिन 90 मिलना बहुत मुश्किल है रादर देन 10 खर्च करना है. इसलिए आप चाहो या ना चाहो, आपसे खर्च हो करके स्टेबिलिटी मिलेगी. आइए प्लीज नोट इट डाउन. रुचि अग्रवाल वो ऑक्टेट पूरा करना है, इंटरनल कॉन्फ़िगरेशन उसका नहीं देखना, आउटर ऑर्बिट में 8 इलेक्ट्रॉन पूरा करना है, ठीक है। सो आउटर ऑर्बिट में 8 इलेक्ट्रॉन पूरा करना पर्पस है, और 8 इलेक्ट्रॉन पूरा करने के बाद वो किसी न किसी इनर्ट गैस के जैसा दिखने लगेगा। तो उसका टारगेट तो होता है कि उस रो में जो इनर्ट गैस है उसके जैसा दिखे, उसके जैसा नहीं दिखेगा तो उसके नियरेस्ट अबाउट जो मिल जाएगा उसके जैसा बनने की कोशिश करेगा, ठीक। जरूरी नहीं जीवन में हर टारगेट अचीव ही हो। आप में से बहुत सारे लोग आईएएस की तैयारी करने का टारगेट बना के आए होंगे और अब एसएससी की तैयारी कर रहे होंगे। तो targets are made for the better things, but sometimes if you are not able to achieve the target तो उसे थोड़ा कम पे compromise कर लेते हो, वही हो रहा है। चलिए तो आज की कथा को यहीं पर विराम देते हैं। Let's stop here today, and tomorrow onwards I will be continuing here onwards, because in 5-6 minutes I am not in mood to start the new topic and I cannot do the justice with any new topic. So tomorrow 9 o'clock onwards we will be starting here onwards. यहाँ के आगे till now what we have got, we have understood कि why atoms are participating in various activities, because they are wanting to achieve the stable configuration. Stable configuration would be achieved when they will have 8 electrons in the outermost orbit, means their octet would be complete, then they will become stable. So in the next class we will try to explore how they are going to achieve this stability. For example, I talked about the money, कि I am teaching because to get the stability, but to teach you I have to come out of my house and I have to interact with the students. So I have to make a bond with the students, then only I can teach and then only I can get the stability. What I am wanting to tell you, कि any atom cannot become stable if it is keeping all its electron in its house. It will become stable only if its electrons are coming out of its house and they are interacting with the some neighboring atoms. Some neighboring atoms means some students. So if they interact with some neighboring students, they make bond with them, then only they will try to get the stability. So in the next class we will try to see how the atoms are bonding with the neighbors, how I am making a bond with you to get the stability. That would be the matter of discussion in the next class. आज के लिए बस इतना ही. Thank you very much. Have a wonderful day. Thanks a lot.